With this volume of America's achievements in space, you will travel from Earth's orbit to Jupiter, Saturn, and beyond. A magnificent pictorial record takes you from fiction to fact, from the imaginary invasion of Earth by Martians in 1938 to the real-life exploration of the outer planets by probes from Earth in the 1980s. Hello again, I'm Jim Lovell, your host for this exciting journey through 25 years of American space history. A journey presented by the Eastern Press using official film documents from NASA. I was only 10 years old when Orson Welles panicked thousands of radio listeners by announcing the landing of Martians in New Jersey. On this tape, Orson himself tells you about the origin of that broadcast and the astonishing reaction to it. It was fiction, but only 41 years later, a robot from Earth reached Mars to explore the so-called canals of the Red Planet. Even before the Mars landing, the 1930s fiction of Buck Rogers had become the 1960s fact of men reaching the moon. By 1966, astronauts Neil Armstrong and David Scott chased, caught, and linked up with an unmanned spacecraft. It was the first docking of two spaceships in orbit, and you'll see it, just as Neil Armstrong saw it. You'll see the unmanned Agena get larger and larger in his window, a beautiful ship, glistening with sunlight against the blackness of space. Neil Armstrong, of course, went on to make the first landing on the moon in 1969. I followed him there in 1970. But we were just local commuters compared to the robots that flew to Jupiter and Saturn. The tape you're about to see will show the story of Voyagers I and II. They made journeys that lasted years and sent back astonishing pictures of planets and moons, billions of miles away. You will see photographs so magnificent that scientists found it hard to believe the reality of what they showed. Many scientists hoped that such missions would find signs of life elsewhere in our solar system, that life didn't exist on just one small planet in a remote corner of the universe. Orson Welles explains clearly, poetically, why so many scientists believe that there must be life on other worlds, some of it intelligent life. Let's just hope that they are friendlier than the Martians who invaded New Jersey in 1938.
February 1979, Pasadena, California. Lights burn throughout the night in the science offices, control centers, and computer areas of the Jet Propulsion Laboratory. Hundreds of scientists and engineers convene here, drawn worldwide from research centers and universities.
I want to go auto back here, put in one FRO, and all the way through the time period with one start.
Makes sense.
By the end of the month, photographers, television crews, and other members of the press arrive.
You guys have any questions?
They are drawn to the laboratory by two Voyager spacecraft, electronic robots sent by NASA to explore the giant planets Jupiter and Saturn.
A little while ago, I heard the remark that images...
Voyager I's exploration of Jupiter is continued in the summer of 1979 when Voyager II approaches Jupiter and its moons. And in 1980 and 1981, each spacecraft explores Saturn and its moons. Their cameras transmit 60,000 photographs of these strange new worlds. Subtle details not visible in the photographs are computer-enhanced in the laboratory. Scientific data are received from a mix of instruments that probe the planets and the fleet of moons that escort them, sensing magnetic fields and measuring violent spheres of radiation.
Error, 0.75 hertz, BCO.
The teams of scientists meet daily to review this flood of data, to cope with the new and unexpected. And team members report their findings to the waiting reporters and through them to the world.
If this is a shear zone,
The reporter and scientist weld a close relationship in a mutual need to understand and communicate what the Voyagers discover.
rather than tilted the other way.
And the estimate is that the crater is 15 kilometers deep and the central peak is 15 kilometers high. Read it?
One tends not to believe the reality of what is there, says one scientist of the Voyager discoveries.
Al, I don't think I really understand how these three images are related to each other.
They're taken.
We've seen things that are different, says another,
I mean,
and things that are begging for answers we haven't got.
yeah, but where is this edge on this view?
Where else we gonna go? Oh, beautiful.
Isn't that nice?
Beautiful.
Just as Galileo's discovery of the large Jupiter moons left a scientific legacy for all of us, says Dr. Edward Stone, project scientist, so do the stunning discoveries by Voyager provide a similar legacy for future generations. The Voyager team of engineers and scientists spent 7 years designing and planning for the exploration of Jupiter and Saturn. The spacecraft are endowed with intricate logic systems and, when necessary, can make their own decisions without contact from Earth. They carry instruments for 11 science investigations of the outer planets and their moons. The radio link with Earth is channeled through a large dish-shaped antenna that dominates the spacecraft. 2 television cameras are the eyes of the spacecraft. They can be aimed with great precision. These instruments detect the unseen forces that swirl around these distant worlds. September 18th, 1977. Voyager is 7 million miles from Earth. Its cameras turn back to record the blue Earth and crescent moon together in a haunting photograph of our home in the solar system. 14 months later, Voyager I's cameras transmit the first photographs of Jupiter. February 5th, 1979. From a distance of more than 17 million miles, Jupiter and 3 of its moons are caught in a single frame. At 12 million miles, Jupiter's clouds of gases and ice particles are seen to swirl and twist in strange new patterns invisible from Earth. From a series of more than 4,000 photographs, a time-lapse movie is made that covers 10 Jovian days. The atmosphere is more complex than had been thought. The trajectories of Voyagers I and II enable the spacecraft to obtain photographs which provide different aspects of each of the 4 Galilean moons. Europa, the size of our moon, resembles a cracked billiard ball, but the complex markings are curiously flat, like stripes painted on the surface. Its icy crust is thought to float on an ocean melted by interior heat. Io is the most spectacular of the Jovian moons. Its vivid, mottled surface with oddly shaped blotches of color mystify the scientists. Surely the strangest object ever seen in our solar system. Ganymede is as large as the planet Mercury. Its dark, ancient terrain is spotted with white impact scars. Adjacent areas are cut by jumbled patterns of grooves and ridges. Callisto is the outermost of the 4 large moons. Every inch of its surface bears the scars of billions of years of cratering. Two scientific discoveries occur during the first flyby of Jupiter. On March 4th, 1979, Voyager I's cameras photograph a faint ring of particles surrounding Jupiter. Several months later, Voyager II photographs the dark side of Jupiter. backlighting by the sun, produces a spectacular view of the ring. It is ribbon-like, 3,600 miles wide. Jupiter now joins Saturn and Uranus to become the third planet known to possess a ring system. A second discovery solves the mysteries of Io's bizarre surface. On March 8, 1979, Voyager I takes a remarkable photograph of Io. During a routine study of optical navigation, an engineer sees what at first appears to be a crescent cloud. Scientists soon realize that it can only be a volcanic plume erupting from Io, a huge fountain of molten sulfur, gas, and bits of rock surging upward against the moon's weak gravity. A re-examination of Io photographs reveals other active volcanoes, the first seen beyond Earth. If we could obtain closer views of some of the Galilean moons, the red spot is larger than several Earths and rotates in 6 days. This violent storm has existed for at least 300 years. Its center is quiet, but the outer rim seizes clouds and smaller storms and whips them around the edge of the spot. A series of blue filter photographs assembled to form a movie of the red spot enabled scientists for the first time in centuries of observation to study the storm's motion in detail. Saturn's atmosphere appears similar to Jupiter's, with alternating dark belts and bright zones, alive with eddies that swirl and dissipate their energy into atmospheric circulation. It is the summer of 1981. As Voyager II flies behind Saturn out of sight of the tracking stations on Earth for 2.5 hours, the movable camera platform jams and stops. When the spacecraft appears from behind Saturn, it is programmed to again transmit photographs. But in place of images, only blank frames are displayed on the monitors. The platform is obviously not pointed where it should be.
It's not there.
All the instruments on the platform are put into a standby mode, and project engineers begin to analyze the problem.
I lifted these slew end times out of the SO. Okay, slew end time.
This thing was supposed to scan.
2 days later, engineers find that with care, the platform can again be commanded to move. Despite the fact that Voyager is 1 billion miles from Earth, engineers are able to pinpoint its problem and successfully restore the platform to use. An image reappears on the monitor screen, and the final photographs of Saturn and its rings are sent to Earth.
Okay. There's a shadow crossing. Oh, okay. Yeah, Ellis has drawn what you should be seeing.
The frame's upside down.
August 1981. Voyager II recedes from Saturn on its journey to Uranus and beyond. The recent discovery of 9 rings encircling Uranus and its 5 known moons hold the promise of fresh discoveries. And in 4 more years, Voyager II will reach that planet. Three years later, it will reach the 8th planet, Neptune, and its great moon, Triton. Meanwhile, Voyager I will continue its flight, searching for the unknown edge of the influence of the sun, where interstellar space begins and our sun is just another star in the sky.